cross country. I hope you're watching this. Welcome back, algebraists. So for today, our lesson slaps, one might say, or is fire. Yep, I love it. Love it. I can feel the eye roll. Okay, so as we're looking at this, if I want set builder, anybody shout it out. You know what? That's a lie. Mark, I haven't heard from you. What do I start set builder with? What's the first symbol that I'm going to write? Yeah, I call it a curly bracket. I don't know if it has a real name or not, but that's a good start. I like this curly bracket. Now, we are only looking at the x's right now. Where does this function start, King? -5. Do I include the point -5? I do, right? It's closed or filled in. Do I include this one when I get to it? Is it filled in or is it open? So there's no real point here, right? It's just a hole in my function. And you may or may not have seen that before, but we're introducing it either way. So I have this lovely thing that tells me I'm already saying this is the set of all, what variable are we talking about? X. What does this bar mean? Louder, Michael. Such that. Okay, King, start it off. What do we know is true of X and the range of X that we can use for this? So we start at -5, and X is always bigger or smaller than that? Bigger, right? Any of these numbers where I'm picking an X value, they're larger. So I'm going to say X must be greater than -5. Where's my mistake already? Yeah, I need to include it, right? So, or equal to. And what is X always less to on this first section? 5. Do I include 5? Are you sure? If I said what ordered pair happens when I plug in a 5, do I actually get an output? Rephrasing that, do I have a hole here or do I have an actual point? I have a hole. I'm never going to touch it. That's my less than. Now, this, I did not intentionally give you the curveball, but it's good to see. And I'm going to move this whole thing because I'm going to run out of space if I don't. Okay, is that my whole graph? -5 to 5. Does it keep going beyond that? So this is weird, and we haven't talked about this in depth. I think you've seen it, but if not, here we are. There's another part of this, right? Where I'm going to literally say the word and. We've already taken care of this. It's between -5 and 5. What is this part of the graph? X is what? Is it stuck between values? Is it just one constraint? X is greater than 5. This was a much harder problem than we did yesterday, and that's okay. Looking at this, first question, have you guys dealt with using and when you're doing things like this? Okay, you may say no. If so, I totally get it. When we do the interval, I think you'll look at it and go, okay, we have done this. I think, but it's rusty. What about interval? If I want to start, I include the -5. How do I indicate that if I'm talking an interval? The bracket. All right, so here we go, bracket. And this one is so much easier. I'm going to start at -5 because I include it. How far do I go along the X values? So when we think about that, I'm imagining that I'm dragging a point across, but I'm wondering what values down here get used for that point. How far to the right do we go, Ronaldo, until we run into weird stuff? Yep. So I'm here, I'm good. I'm good, I'm touching it, I'm touching, still good, everything's fine, living life, looking good, uh-oh. So from -5 to where? Do I touch that 5? And by that, I'm not literally meaning do I physically touch it. If I were to put my X value at 5 and go straight up, do I hit the function or do I just go straight through it because there's a hole? I go straight through it. How do I indicate that I don't touch this number 3? I don't know who's number 3 today. Zed, how do I indicate I don't touch it? Bracket is touch. What's not touch if you check your notes from yesterday? Michaela, help out. What? I heard you whisper something confidently. Parenthesis. Check it out. We don't touch it. Now, this part is where we're going to really determine whether or not we've seen this before. I need to tie this interval from -5 to 5 together with this side, but I need to skip over that 5 value because of the hole in my graph. How many of you have seen this symbol when you're writing things like this? Okay, It's been a long time since I taught Algebra 2. I thought that was an Algebra 1 idea. That's okay. We'll hit it right now. This U-looking thing stands for a union. It is the same way that we write and in this notation. I then start at 5 again. I don't touch it. How far do I keep going? Seabass, how far to the right can I choose an x value that it'll still hit this function? Like, if I pick this x all the way over here, I'd have to go way up, but will it hit that function eventually if I go straight up? So how far to the right can I go where that keeps happening? It happens at 10, it happens at 20. I bet it will happen at a trillion and a quadrillion and a Google. Infinity. Can we ever touch the number infinity? So think of the number infinity in your head. Okay, that's the biggest number possible, right? Add 1 to it. Were you really at infinity? No, right? So infinity is this weird idea. It's not really a number. It's just this idea. You can never touch infinity. If you're ever writing infinity in an interval, always a parenthesis. Always, always, always. You can't touch infinity. Okay. That one's kind of tough. The second one, B, I think is a little bit easier. Let's see. B is for Bice. Kennedy, do you want set builder or interval? Interesting. Love it. Okay, I'm going to work with the set of all x such that where does my function start? What x values do I actually get to start at and plug in? A, do I include it? I don't like the way that x looks, so just bear with me. If I were to pick x here and I go through it, do I actually touch a function or do I shoot right through that hole? So if I don't include it, it's not going to be or equal to. So I know that x always has to be bigger than a, everything to the right of it so far. So let's do that first. A is less than x, or if you read it from right to left, x is greater than a. All right, Lily, I start at a, and then as soon as I get to the right of a, I can start plugging it in. I'm good, I'm good, I'm good. How far can I go that I keep doing this? To B. Now, here is just a purely my sloppy writing. At point B, is that an open hole or a closed hole? Like, is it filled in or not? It's open? Okay, if yours looks closed, it looks open when I look at it here. If you had it as closed, leave it. Don't change it. I'm going to change it to closed right now up here. You can keep yours as is. If this is closed, I go until I get to B. Can I include B? If it were open here instead, would I include B? No. So it all depends on whether that point is filled in or not. There is my set builder for this one. We have it. Okay, who wants interval? Or who's going to really try hard to avoid eye contact with me is really what I'm looking for. All right, we'll let the calculator decide. Interval notation, I think, is easier. Number 6, what's your gut tell you? That is Kennedy. I'm not going to make you go again. Hawaii. If we want to write interval, where does my function start? What x values do we start plugging in? At a. Do we actually include a or just as close to a as we can get? So how do I indicate that? That's correct. Okay, I start at A. How far to the right do I go, Perscovia? I go to B. And do I include B on my graph up here now? It's filled in. I include it. And what's the symbol that I use to show that I actually use it? I bracket. Yep. Boom. Cool. Now, these ideas. Sorry to introduce stuff that you hadn't seen before. I didn't mean to make the examples harder, but that'll make the homework easier by comparison as well. As we look at this, I'm asking you guys specifically about the x values for this function, right? Well, dang, I think there might be another name for this that maybe you've heard before when we talk about functions and stuff that I can plug into it. It starts with a D and ends with domain. Oh my gosh, it's the domain. So we have a couple examples where I just had you guys help me calculate out domains without ever having to use the word. Two things that I've seen people think is extremely hard over the years, no matter which math class, all the way from Algebra 1 up through Calculus, people get goofed up on domain and range. If you can identify the x's, you have half that done already. We're going to sneak in some key features of functions, which, just to show from yesterday, that's where we started, key features of functions. So we started with a little bit of vocab. We're going to add some more in. We're going to define for ourselves the domain of a function. And I want to stress again, anytime that I'm writing caps, that is a vocab. Okay, There are inevitably going to be times where I try to be way too formal with how we define stuff. Right now, you're kind of like the middle of the road of where our math stuff goes in high school, right? We're a couple classes beyond this, couple classes before this. As we look at it, we're going to start introducing a little bit more of that formality stuff that we saw yesterday at the start of class. So for a domain, this word I imagine looks familiar to everybody. Is that true? Does anybody think you can explain to me, based on the examples that we just did with domain, what a domain is? Okay, so that's a tough question, especially on the spot. 30 seconds, try to come up with a way to word the values that we just found for those two graphs on A and B. 30 seconds from now, I'm going to call somebody random. Get loud, get talkative, go. So I'll even start it. I want you to fill in the blanks for me, okay? I'm going to say that for a function, the domain is the set of all. Which values are we checking for the domain? Only two choices in any function, independent and dependent, x and y. X. The set of all x for which our function is defined. Now, this is fairly formal. When I think about this and when I question you guys about this, when I talk about is it defined, I just mean is there a point for that x value? So you might hear me use other words for this. I would say this function looks broken, the left one especially, at 5, because there's something wonky that happens. I can't pick those x values. I use the word broken, although the correct language would be that's just not part of the domain. Okay, when we write this, always, 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 domain is all x every time. On the other side, if I worry about what x's can I actually plug into a function where it works, I'm also worried about what values does it spit out. When you guys have studied this before in previous classes, anytime you've asked about the domain, there's always been another side of this. The range. Now, the cool thing is that we can generalize this and just make one little change. For our work, anything that we do, there's only ever going to be two variables. If x and what we get to plug in for x is all of the domain, the range is going to be what other variable? The y. But do we plug in y's into our function? No, we plug in an x and the function spits out our y value. So with that then, using the same idea but with y, I want you guys another 30 seconds. Let's get a good definition for range. Maybe not 30, but start now with your neighbors. Define range in your own words. As we look at this, somebody finish this. I'm not going to call a number, just shout it out. The set of all y values such that what? The function outputs. The set of all y values that a function. Now, we can use the formal word output is fine. More casually, I like to use the term it spits out. I put something in, it spits something out. I'm going to refer to that as output right now. Okay. We have domain and range, inputs and outputs. That's all that we are worried about with these things. Now, people get goofed up. You will try to mix up domain and range, but let me just check real quick. Does everybody in here know the English alphabet? Yeah. What comes first, X or Y? Okay, so I always put X first on my ordered pairs. I use that there. What comes first in the alphabet, domain or range, D or R? So domain comes first, just like X. This is all X's. Range comes second, like Y. That's all Y's. Now, for these, in these questions that we worked above, was I asking a question about the domain or was I asking a question about the range? Only the domain. And I can tell that, King, because in each of these examples, and even the name here, I'm writing the what interval? X. Only the X's is what we were asked about here. That tells us we're only asking a domain question. Now, when we look at these, domain and range can be done a few different ways. We can determine the domain and range from a graph, which is what we just did. We can determine the domain and range from just the function defined as f of x equals some big equation. It is a bit harder, especially the range, to do it from the equation, but let's get a little bit of practice here. I'm going to sketch an example where I want us to do both of them. I want us to find domain, and I'm going to shorthand DOM, and range of each. So a domain and a range for, we're going to do a couple graphs right off the bat. Or a graph and then maybe not a graph. So let's check our first one out. I'm not going to put any time into making my graph perfect, scaled, or anything like that. I'm not going to worry about it. I'm going to just have my coordinate plane here with my x and y axes identified. And I'm going to draw a lovely curve. What's a parabola look like? Kind of like a U. Not quite a U, but we'll talk about why that is. But does this look like a parabola that you guys have seen? Or at least the shape of a parabola? All right. So I'm going to put this value, only one that I care about right now because we're not actually graphing a function. Let's say that that is a -2 right there on the axis. Cool. I'm going to name this function f of x. That's what we'll refer to this one. We could figure out what it's defined as, but it's not my focus right now. I want us to find the domain and range. Are we doing this as a whole class, or are we doing this with your neighbors and then just debriefing together as a whole class? Whole class, all right. So, everybody have this, anybody need more time to draw? Okay, you will see I do not like to write a ton. My shorthand, instead of writing the word domain and range, I'm not saving a lot, only a couple letters. But if I write DOM, what do we already agree that that stood for? Domain. So if I write the domain and then I put this, what do you think I'm asking? The domain of what? The domain of f of x. Now, we can do this in interval. We can do this in set builder. I'm okay with either or both. As I look at this function, we always, left to right, just like we read. I didn't draw it forever, but if I wanted to plug in this x value, do you think it'll eventually hit that function up here? So, Jetty, how far to the left could we go that we would still hit the function if we went straight up? Infinitely far. So, we'll go ahead with set builder first. I'm going to start, interval first. I'm going to start all the way at -infinity. Notice, I can't touch infinity. Hence the parenthesis. So here we are, -infinity. Love it. How far to the right do I keep going? I would hit it at -infinity. I would hit it at -10, at negative whatever. Would I still hit it at 5? Yeah. If I went straight up, will I hit the function? Like there's a point that has x equals 5 as its x coordinate. How about a billion? Yeah. A trillion? How far to the right can I keep going? Yeah. Infinitely far. So as we look at this then, I start at -infinity. I don't touch it, of course. And I go, how far did we just determine? Positive infinity. Is there an easier way to write -infinity to positive infinity? Maybe a blackboard letter of some sort. Naomi, go with your gut. Yeah, I like it. Not naturals, because we included negatives here. It's the reals. So, the other way to write this, if we knock it out in set builder, every single time, and this is the one that I would prefer, it's a set of all x, such that, and we're going to work on that fancy math shorthand that really and truly is what mathematicians use. X can be literally any number, right? Anything from negative to positive infinity. So I know that that means that, hey, I can pick any x such that x is in the set of, that's what this little euro symbol means, in the set of, and we're going to stick with the reals. And we have our entire domain listed. I don't care unless specified whether you use interval notation like the top part or if you use set builder like the bottom. I want you to be comfortable with both. I prefer the bottom, but you do you. Cool. Okay. Seems okay. We'll just do thumbs up. I don't know if I said 5 or not. Thumbs up says, yep, that seems okay. Thumbs down says, yuck. Anywhere in between. Where are you at? You don't have to broadcast it. Okay. Cool. So, we'll do another one as a group, but there's a whole second part of this problem we got to knock out. What? Cool. We talked about the domain. There's a natural additional question. What's the other one we're going to deal with? The range. The range deals with which values as we're going through this, Lando? The y intervals. So check it out. Same thing. The range, RAN, of this function that we're looking at, which is f of x, equals, and I'm going to switch the order that I did it. No particular reason. I know that the range is a set of all y such that something's true about it. I'm going to let everybody catch up before I point to stuff. When I look at a y value, like y is -5 maybe, This horizontal line is y equals -5. Does that ever touch the function, or does my function ever give me a -5 value? No. Does it ever give me a -10? No. If I start at -infinity and I start working up, where's the first y value that my function will hit or include? -2. And it does include it, right? There's no hole, there's nothing weird happening. I'm going to start my y at -2. How high up can I keep going where I'm still at least touching the function once? Infinitely far. So I could say that it's -2 to infinity, right? Is there an easier way to say that? Can I write that as a single inequality? Something is true about y if I go from -2 to infinity. Love it. Who said that? You were right, whoever it was. I just want to give you credit. Why would you be shy about that answer? Lily, you're smiling. Nice job, Lando. All right. That's it. Y is greater than -2. Piece of cake. What if I wanted it as an interval? I've said it a bunch of times. Maybe you didn't catch it. How do I say the interval from here up? -2 to infinity. Love it. I need the symbols that you're going to put on the outside of this, though. What symbol goes here? The bracket. How about here? Parentheses. Boom. We have it. Okay. There are additional examples. Like, we're going to do one more. And I want to make sure that we have resources to do this. How many of you guys use Desmos on your calculator or on your phone? How many of you have used Desmos ever and you know what it is? Okay. Desmos is an incredibly powerful free graphing calculator, geometry calculator. It does more than you'll ever need it to do. There is an app on your phone that I would encourage you to download, but it's entirely up to you. Here is, I'm just going to go home so I can zoom back out. This is Desmos right here. If we make up some function, and I'm just going to make one up, you don't have to draw it, but I want to be able to look at this. Let's say we have f of x is x, I don't know. What's your favorite quadratic function? Okay. Let's say it's -x squared plus 4. Okay. For this particular function, here it is. I can see the equation. Maybe. What is going on here? All right. Bear with me. There we go. I can see the equation. It's x squared plus 4, -x squared plus 4. I can see the graph. Which one do you think is easier for us to make sense of the domain and range from? If I said forget about the picture and said just this, can you tell me right off the bat what it is? Not super well. You will be able to. Not today's focus. From the graph, can we do it? Prove it. I'm going to call this function g of x. You don't have to draw it in your notes. I just want to make sure that we practice. If that function is called g of x, I want you, I'll put it back on the board. I want you to find me, though, the domain of that function, g of x, and the range of that function, g of x. Again, you do not have to draw the graph. I don't want you to need to take the time to try to graph it perfectly. We have the graph on the board in 3, 2, 1. Okay, got me. 60 seconds with your neighbors. Once I check, or you have an answer to check, let me know. I'll check it, and then you can then help your peers in class. Domain and range of a function we need, g of x. I'm going to let you choose. It'd be good practice for both. So, I feel like you get some. Okay, so like, and that's okay. You'll probably go yes, no. When I look at this, because I know it's a parabola, is it, like it starts to get steeper, but does it keep going that way? Like if I zoom way out, I think it will. How far that way could I pick an answer? Like, can I plug a -6 in and it still gives me an answer? It'd be -36 plus 4. Could I plug in a -50? Like, there's nothing weird that happens, right? I don't divide by 0, I don't do anything weird like that. So how far can I keep going that way? Boom. So there's our domain, because we're looking at the x side. We start at -infinity. I don't run into any issues. No issues. I can still touch. No issues. No issues. How far to the right? Is there an easy way to say negative to positive infinity? What is it? You can do it like that, negative to positive, or you can just do that handle it also. 5, 4, 3, 2, and 1. All right. So wherever you're at, you're welcome to keep working. I'm going to zoom out a little bit. Right now, where we had it zoomed into, it looks like, I don't know, I can see it gets like to negative 3 point something. If I zoom way out, it's going to look less like a parabola because it's going to look steeper and steeper. But notice, I can get to negative 6 or negative 7. Can I keep going and going and going and going? How far? Negative infinity. How far to the right can I go? Positive infinity, right? So how would you express this then? The domain of this function. So you want to use set builder? I'm cool with that. X such that X is in the set of what numbers? Not the range. What's that R stand for? Real numbers. Or, and either one of these is fine, don't change your answer. If you had listed this instead, I'm equally good with it. Negative infinity to infinity. Both are fantastic. Do you guys have a preference yet for which of these notations we use? You like set builder? Who agrees with Angel? That's about what I figured. Like intervals, less writing. I don't know. Let's see. Who haven't I called on? Julia. I don't think I've called on you since we've been in class. For this function, what would you say the range is? Our y values. I love the numbers, but I want to see if we as a class can agree on where we could write that a little bit clearer. You said 4 to negative infinity? Okay, before you write this, let's dig in. Bracket or parenthesis here? Bracket on the 4 and parenthesis here. I like the numbers. I don't like the answer. When we read on the x-axis even, we go left to right. We've done that with the x's. That's negative to positive. Up and down doesn't seem as natural to say, but can we go negative to positive in the y direction as well? I love everything about this except the order that you've given them in. We always start negative. This answer I would not count you wrong for, just so you know at least to begin with. The real answer, we use everything the same, but we always say where do we start in the negative? Negative infinity to where? 4, and we have it. Domain and range knocked out here. Okay. Thoughts? Feels okay? Feels awful? The set builder for this one, this would be the set of all what values? Because we need to put, just kidding. The set of all y such that, is there a single inequality that we could write for this? Greater than something or less than something? We only use values greater than 4? Less than. Can we use 4? So it's not just less than. Hey, y such that y is less than or equal to 4. And we done. Piece of cake. I hope. If you're still struggling with this, is that okay? Yeah, for sure. You can come to me before school, after school, at lunchtime. Shoot me an email, never a text. Awesome. Okay. Do we need a brain break? I heard no. Okay, cool. I'm going to try to give you a little bit of time for homework, so we're going to kick in right now. Okay, I don't think we need to write this part down. Maybe. We'll see if we have to summarize. So I'm going to keep this graph up here. Are there sections on this graph where we could probably all agree that it has negative values? Yes. Now, I'm going to start dragging it. Is this a point where it's negative? Yes. Okay. I want everybody, like, obnoxiously loud. I want Miss Val to hear it with the understanding that Miss Val is not even in this building, right? She's down in Portland. So loudly, I want you to shout when I am at the point where I'm going to go from being negative function to a positive function. Okay? Okay, let's just practice once. We'll go loud on 3. 1, 2, 3. Perfect. That was awesome. Okay. Realistically, like obnoxiously loud, like 1, 2, 3, like loud. Okay? All right. Here we go. Do-do, still negative. Okay. All right, we're going to try it again. Hey, I like it. All right. So at this point, I am making the transition from being negative to positive. Notice, when we ask if a function is negative, am I looking at the x's or the y's? The y values. If I say when is a function negative, I'm just asking when is it underneath the x-axis. Is there a section where it's positive? This section right here. Everything there above the x-axis. If we need to summarize that, we can. But if you guys know that positive means positive and negative means negative, we can identify these things reasonably well. Okay, some important key features that we're going to see. Using the language that you can remember from what you've seen in math, does this point right here have a special name? This is not the origin. If you can't tell where I'm pointing right there at that thing. That's not the origin. It is the intercept. It's one of them. Which intercept? X or Y? The x-intercept. There are three other words that you likely use when finding x-intercepts. You might not even be aware of it. What's the y value right here? So you gave me the x value. What's the y value? So when we're looking at this, everybody has seen the word x-intercept, guaranteed. I think all of you have probably seen the zero of a function as well, or the zeros. Any other words? It's not undefined. That's a good thought, though. If we divided by zero or something weird, it would be. The word root is something you've probably seen before. And there's one more, the solution. The solution, the root, the x-intercept, or the zero, they're all the same thing. Okay, do we need to write down what it means for a function to be positive and negative? Okay, what's this thing called again? X-intercept or root or solution or, what's this y value here? Zero, the zeros. That's what I would prefer to use. Okay, we're not going to jot that part down then. I'm trying to decide if I want us to just keep rocking or if we want to have a little bit of time to start. We're going to do this differently than I normally do. We're going to start the homework right now. I'm going to let you guys work for a few minutes. We'll see how far we get through it. My goal, just so you know, I do not intend to make you do stuff over the weekend, even though I give you the textbooks. Okay, so let's check this out. We are going to work only a few problems here. I want for tonight, and before you start writing it down, I'll just highlight here. Any homework assignment that you give me, we'll check this on Monday. We'll go over it. I'll probably add to it Monday is what's going to happen. This first lesson, does it feel like I'm going painfully slow to anybody? Does it feel like we're moving slow or fast? I think we're moving kind of slow, but that's okay because we're getting into it for the first week, so you can kind of get a feel for me and I can get a feel for you guys. When you do homework, if this is your page, which I will physically collect your homeworks, just so you know. So here's a sheet of paper. What I want, if it were my assignment, I'm going to write my name, top left. Cool, that's me. Don't call me Kyle. Okay, second thing, and we'll try this one. We'll do a few minutes, pretty chill day. I want you guys to write down the following. This is every homework assignment will have the same format. Homework 1.1. If I don't tell you the page, I want everybody, don't shout it out. Find me homework 1.1 and where you think those problems are in your text before I write a page number. Do not shout it out. Open your text, find me where the homework for 1.1 is. Are you finding at the beginning or the end of chapter 1, section 1? The end. So in your book, in the bottom right corner, you will see lesson 1 dash whatever. So right now, you're starting chapter 1. If we just nope, you're going too far. If we just go a couple pages, so now I can see that we're in 1.1. We're just going to go to the end of this section. Okay, so most people have found what page are we looking at? Page 11 or 10, depending on which side you're looking at, right? So when we do this, I will try my best to give you the page numbers. If it's ever wrong, this is what you care about. I don't care if I write down the wrong page. It's at the end of section 1. Okay, super chill assignment for today. Homework 1.1, it is on page 11. I want you guys Only 4 quick problems, 12 through 15. And then last little thing, I will be able to tell that this is algebra based on what we're doing, but I would love it, and I need you to do this. I need you to write first hour, first period, whatever you want to write for it, because I have another algebra class and I'm going to get them mixed up if somebody just leaves one. Cool. All right, you guys have like 8 minutes. Realistically, there's a very good chance that you will finish this assignment in the next 8 minutes. Cool. I'm going to give you guys time to work. Baller. Music, what do we want? Okay, quick question. Maybe what? Daily Dose. We're not watching a Daily Dose. Uh, Anybody in here ever heard a swear word? Okay, purely out of curiosity, how many of you use profanity, swear words, cuss words in your like regular usage, not in school? Do you think I speak profanely? I swear. Yeah, I'm terrible. I've gotten better with a kid. Right? Most people do, not everybody. Uh, okay. Have you guys all heard music with swear words? Okay, here's the deal. I will never intentionally pick it, but I also just kind of willy-nilly put stuff up to listen to. If there's profanity, are you going to report me and get me fired? Okay, deal. Easy. Yeah, I don't really think I would get fired for it either, but not really a risk I'm willing to take. All right. I mean, obviously it is because I'm about to take that risk. But here we go. Is lo-fi too low energy for everybody this early in the morning? I sure like this duck. If you guys hear a song that you know is going to get like way too out there with sex or drugs or anything like that, give me a heads up because I don't know any of these songs. I just like the duck picture. Cool. All right, I'll post the video to YouTube right now. You guys are cool to collaborate, talk with each other on homework. Don't copy, that's not going to help you learn. And no matter what I'm doing, what is my primary focus for the next 10 minutes, 5 minutes? Who's the most important people in my world right this second? Okay, so in this classroom, who's the most important people? You. Nothing that I'm doing is more important than helping you. Questions, I like to answer, I like to help. I'm a resource. Use me as a resource. Cool. I'm going to post the video. I don't like that one. I don't like that one. Okay, with homework, you don't have to write down the whole problem. I just need the answer. If it's like a function thing, like if you're going to factor f of x equals, which we're not doing, you need to tell me what f of x is. But you don't need to write word for word the question, like your textbook has that all. I don't need it. Cool.